All right, welcome back. This is the Jake of all trades. In our last video, we went over how to find the average on your dice to make sure that they are rolling at a statistical average, because that's going to have impact on what we want to do next, which is roll our dice against each other to determine what the difference is between an advantage slash disadvantage on a roll versus just a flat roll. So let's get into it. I'm getting ahead of myself though. Before we get to that, we should get to address what is the most overlooked feature of dice averages. Well, when we look at all of these averages that we get, when we go back through, we find that the average on a D20 statistically should be, wait for this, and everyone says 10, right? Everyone thinks 10, but it's actually 10.5, and I'm going to tell you why. The reason is, and this photo of our D20s actually kind of displays it well, but if you are looking at a D20 at any time, the opposite sides always add up to 21. And so you have 20 on one side, on the very opposite side is the 1. If you add those together, it's 21. And if you divide 21 by 2, you get 10.5. So, and the same goes true for any number on your D20. Go ahead and look it up now. If it's not, if it's one of those, like there's like 20, 19, 18, 17, 16, I'll try to find another photo over here. But if you find one of those are not D20 dice. And the reason is because they're not statistically average. The reason it being that all of those large numbers are lumped on one side and all the small numbers are lumped on the other side. Statistically, you still have the same chance of rolling any one of those numbers on the D20, but with those type of die, you it gets swingy, right? Like the die, like on the D20, standard D20, it's like a 17 is next to a 3, a 10, and a 7. It's not next to an 18, a 19, and a 20. So, that's the reason why. A few notes about how I managed, how I was averaging my numbers and things you might want to keep in mind if you choose to do this yourself. A couple things, there were some research flaws, specifically the dice pit was one. If you wanted to have very accurate rolls, you would use something maybe like, a dice tower or something like that. And then if you just push it off the same place every time, you're going to get a consistent roll. Basically, when I'm throwing it in the dice pit, sometimes it rolls around in the pit, sometimes it smacks against an edge and stops. So it really, that's a research flaw there. Another one is just human error. I'm subject to make mistakes. Sometimes if I'm rolling really fast, maybe I thought it was a 6, maybe I thought it was a 9, maybe I only added up 99 instead of 100 numbers, and I divided by 100. Maybe when I was trying to type it into my calculator, I mistyped a digit or two. Maybe I accidentally subtracted one instead of adding one if I was doing it on my phone calculator. It's little human error, things like that. Can also impact your results. So ideally you want to do more than 100 rolls. I sat down and I chose my 3 oldest dice, which also in the first 100 rolls they were also the most statistically average dice. I took my 3 most statistically average dice and I rolled them out another 900 times a piece. And I'll throw up some pictures here too, so you can get an idea what that looks like on paper. So if you do want to write it down, I would suggest graph paper, because you can write little numbers in one box, and if you count out 25 boxes, you can do 4 rows, and that's 100. That's what I did. Another thing though is I would just recommend skipping the graph paper and skipping writing it down, and I would just go right to an Excel spreadsheet or a Google Docs spreadsheet or something like that, because typing it in it just reduces, it cuts your human error technically in half, because you only have to worry about entering it once, whereas when I'm writing it down and then I'm entering it on a calculator, technically I have to worry about entering it twice. But if you're just worried about entering it on the spreadsheet, you only have to enter it once, and then you can use some Excel formulas to get your average for you, and it'll be a lot faster too than typing in every friggin' number by hand, adding them up and dividing by 1,000. Trust me. Those are a few takeaways that I would give you if you choose to do this yourself. It can be fun, but it's just a huge time suck, so don't do it unless you have time to kill. So now that we know our dice are accurate and we know that the true average on a d20 is 10.5, we are ready to get down to business and see what does advantage and disadvantage look like statistically on average. Is it close to a +5 or a -5 modifier, or is it something bigger than that? This could potentially be some really good stuff, some really good information for you game masters out there, even you players out there who might be trying to argue for advantage. Maybe it's a lot not as strong as we thought it was. Who knows? Let's find out in the next episode, huh? Here's a link over there. Go check it out. Thanks for joining. I've been the Jake of all trades. You have a great day, and we'll see you again real soon.